Hi guys, we're going to discuss slopes of parallel and perpendicular lines a little bit today, and as well equations of parallel and perpendicular lines. So it is, again, it's just a review. I know you've seen it before and had it before, so we'll just refresh your memory a little bit. We want to determine if lines are parallel, perpendicular, or neither, and we want to be able to write the equation of a line parallel or perpendicular to a given line. This is a topic that is kind of, I mean, it only comes up maybe once or twice on the ACT or PSAT, but it is a question that is usually asked somewhere in there. So it's a good idea to just refresh your memory about slopes of parallel lines and perpendicular lines. If two non-vertical lines are parallel, so we're talking about oblique or diagonal type of lines, something like this, okay? If you have two non-vertical lines that are parallel, then their slopes are equal. Their slopes are the same, okay? If the slopes of two distinct lines are equal, this is the converse. And the converse is also true, that if the slopes of two distinct lines are equal, then the lines are parallel. So that's just the converse of the first statement. And any two vertical lines or any two horizontal lines are always parallel. And since the reason why we have that statement separately is simply because recall that the slope is undefined for vertical lines, right? Undefined for vertical lines. And so we kind of want to include that statement because we can't really calculate the slope of vertical lines in a sense. All right, so let's talk about slopes of perpendicular lines. If two non-vertical lines are perpendicular, right, that means they intersect to form right angles, then the product of their slopes is -1. And another way to try to understand that a little bit, it also means that their slopes are opposite reciprocals. And so what I mean by that is by opposite, I mean opposite sign, and reciprocals means that you would just flip your number over. Recall that numbers like numbers like 1/2 and 2 are reciprocals. So, for example, if you want an example symbolically, if the slope of a line is m, then the opposite reciprocal would be opposite -1/m. Okay, that's what would be the opposite reciprocal. And if the slopes of two lines have a product, this is just the converse, if the slopes of two lines have a product of -1, then the lines are perpendicular. And lastly, about perpendicular lines, if you have a horizontal line and a vertical line, those are always perpendicular to each other. And again, it's not something that you calculate. Since you cannot calculate the slope of a vertical line and that slope is undefined, then you just need to know you can't multiply those slopes together and get -1. You can't say that the product of the slope of a horizontal line and a vertical line is equal to -1. So you just want to understand that that is always a true fact. So we're just going to go through a couple of quick things. We really want to focus, I'll take a little more time on writing the equation of a line. We want to determine if line 1 and line 2 are parallel. Here's line 1, here's line 2. And we're going to find the slope of each line. And just to make it a little bit easier, I'm just going to count the slope just because it's a lot faster. We're going to do another problem where we do it algebraically. So from this point up here in line 1, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, and then over 1, 2, 3. So the slope of line 1, is equal to -9/3, which would be equal to -3. Now let's calculate the slope of line 2. I'm going to start with this point. We're going to go down 1, 2, 3, 4, 5, 6, 7, and over 1, 2. So we went down 7, -7, and to the right 2. So I got a slope of -7/2. So these would not be parallel because they do not have the same slope. Okay? Going to double check the slope of line 1, 1, 2, 3, 4, 6, 7, 8, 9. Correct. Okay. All right, let's try another one. We've got line 3 containing the points A and B, and we've got line 4 containing the points C and D, and we want to know if these lines are parallel. So for each of these, I'm going to call, for A, this is going to be x1, y1, x2, y2. 2 doesn't come out very well. And for line 4, we're going to call this x1, y1, and x sub 2, y sub 2. So we're going to first find the slope of line 3. We're going to calculate that algebraically. Recall that the formula for slope of a line is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's supposed to be minus side there. All right, so we've got 2 minus 6 over negative 1 minus negative 13. Remember, that's going to be a plus. So we've got negative 4 over 12, which gives us negative 1/3 for the slope of line 3. Now let's calculate the slope of line 4. And 7 minus 6 over 6 minus 3 is going to be equivalent to 1 over 3. So let's pay attention to what we've got here. We've got the slope of negative 1/3 and the slope of positive 1/3. These are not parallel because they are not equal slopes. Okay. That's going to be our justification. I want to focus a little bit more on making sure you understand how to write the equation of a line that is parallel to a given line. So we have a line, y equals negative 3x minus 5, and we want to write the equation of a line that passes through a different point, negative 1/8, but is parallel to this. And so for parallel, we know that the parallel slope has to also be the same value, negative 3. It didn't ask us for which form of a line to write it in, so let's just start off with point slope form. We're going to start with point slope, and then we're going to simplify it a little bit. So point slope form, recall, is y minus y1 equals m times x minus x sub 1, and we're going to plug in for y sub 1 and x sub 1 and m. So we've got y minus, and this is x sub 1 and y sub 1. So y minus 8 equals, and the slope that we are using is the parallel slope, so same slope, negative 3 times x minus negative 1. Now we're going to simplify this, and we're going to end up writing this in slope-intercept form. Y minus 8 equals negative 3x. Remember, this was going to be a plus, minus 3. And then to get it into slope-intercept form, we need to add 8 to both sides to get y equals negative 3x plus 5. This would make it easy for you to graph it if you needed to graph it. If you want to talk about standard form, just to recall what standard form is, remember that standard form is ax plus by equals c. A, b, and c have to be integers, and a needs to be a positive number, right? So if we want to do that, then we can take our slope-intercept form, and all we really need to do is add the negative 3x, add 3x to both sides, so that we can get 3x plus y is equal to 5. And then everything is already an integer, and a is already positive. Let's talk about perpendicular lines for just a minute, and we'll make it go quick. All right, lines L1 and L2 are neither horizontal or vertical, and we want to find out if they are perpendicular, so we're going to calculate the slope. Here's line 1. Here's line 2 over here. I've got 2 points that lie on line 1, so let's just count the slope again. We're going to count from the point negative 4, 2. We're going to count down and to the right, so down 1, 2, 3, 4, 5, 6, and to the right 1, 2, 3, 4. So for the slope of line 1, we went down 6 and we went to the right 4, which reduces to negative 3/2. Now let's calculate the slope of line 2. And for the slope of line 2, I'm going to count from negative 5, negative 3 to positive 4, positive 3. So I'm going to count up 1, 2, 3, 4, 5. Oh, looks like to me 6, right? And then over 1, 2, 3, 4, 5, 6, 7, 8, 9. So we went up 6 and over 9. And if we reduce that by 3, we get 2/3. Now let's examine those slopes and see if those lines are perpendicular. Recall that if the product of two slopes is equal to -1, then they are perpendicular. Okay? These will cancel, cancel, and you're going to get a -1. Right? All right, so now we're going to use algebra again to do this one more time. So let's find the slope of line 3. We're going to do -1 minus 7 over 3 minus 2 using slope formula. -8 over 1 gives us a slope for line 3 of -8. Then we're going to calculate the slope of line 4. 7 minus 6 over 8 minus a -2 just makes it +2. That gives us 1 over 8. Excuse me. Mistake there. That gives us 1 over 10. Therefore, we can say that line 3 is not perpendicular to line 4. And we can say because product of the slopes does not equal -1. Okay, that's one way to say it, or they are not opposite reciprocals. Now we're going to write the equation of a line that's perpendicular to a given line. So this is typically where students kind of go off the rails a little bit. You want to examine what's the slope of the line that you have given. So the slope of this line is 1/5, which means we need to identify what's the perpendicular slope. The perpendicular slope would be the opposite reciprocal of 1/5, which means the perpendicular slope is going to be -5. We're going to use 15 and -4 as x1 and y1, and again we're going to go ahead and use point slope form to start. So we're going to say y minus y1 equals slope m times x minus x of 1, and we're going to plug in everything we know. Y minus -4 equals, and the slope that we found was -5. That was the perpendicular slope, right? Times the quantity x minus 15, and we end up with y plus 4 equals -5x plus 75, and y equals -5x plus 71. Again, if you want to talk about standard form, ax plus by equals c means we just need to move the 5x to the other side. So we're going to add 5x and add 5x, and we're going to get 5x plus y equals 71. Notice that we don't have any fractions here in the standard form. If you do, make sure you multiply through by the common denominator to cancel out any fractions. There should not be any fraction coefficients for standard form. And that's all we're going to do on slopes of parallel and perpendicular lines and equations.